Okay, today we're going to be looking how to find the missing side of a shape. And these shapes are similar figures. So let's think about first what similar figures are. Similar figures are, for example, a triangle or a rectangle or a square that are the same shape, which means the angle of this triangle will be the same as this angle over here. This angle would be the same as this angle. This angle would be the same measurement as this angle. So the angles are the same, but the lengths of the sides are different. So they're called similar figures, and we can find the missing side of a similar figure by using the proportions that we've been working on. So if we look up at these two triangles, we see that we're trying to find this missing side right here. So what we're going to do is we're going to look up here and look at the triangles. They happen to be positioned the same direction. One of them's not rotated or flipped. So this long side with the 9 centimeters would be similar to the side that we're looking for. And then the 4 centimeter side would be similar to the 2 centimeter side. So we can set up a proportion first with the large triangle. With the large triangle, we could set up either the long side over the short side or the short side over the long side. It doesn't matter. I'm going to set it up with the long side over the short side. So here's the ratio I set up, 9 centimeters over 4 centimeters, or 9 centimeters to 4 centimeters. And that is going to be equal to, now, since we put the long side on top of the first one, we have to put long side on top of the second ratio that we set up. So I set it up x to 2 centimeters. Now that we have that, we're just going to use the butterfly method that we used when solving proportions. We look at the diagonal or the butterfly wing with the two numbers. We multiply them together. 9 times 2 is 18. And that is going to equal the wing of the other one, which is 4x. And then to solve, we just divide both sides by 4. And so the missing side is 4.5 centimeters. So we're just setting up a proportion with similar figures. This one was not on your notes, but I want you to see that not always will the shapes be positioned the same way. The large rectangle on top, if you notice, here is the short side, but on the smaller one, that one has been rotated and the short side is actually on top. So you have to look at the way they're positioned in relation to each other. So the red there are the two short sides, so those are our short sides. And our two long sides are our 24 centimeters and 7 centimeters. Now we want to set up a ratio for the large one. We can either do short side to long side or long side to short side. I chose to do short side to long side. So I have the 12 on top and the 24 on the bottom. So when I set up the ratio for the second one, I need to make sure that I have short side on top to keep it consistent. So I have x to 7 centimeters. We use our butterfly method to solve it. So first we do 12 times 7, which is 84 centimeters. The other, whoops, I forgot the 4 right there. And the other wing we have 24x. And we divide both sides by 24. And when we do that, we find out that the length of the missing side is 3.5 centimeters. So be careful when looking at them. You have to see whether the shapes have been flipped or rotated or reflected. Here's an example of the triangles have been reflected. So when you look at the sides, here you see the right angle on the large triangle. Here's the right angle on the small triangle. You can tell that the triangle had been flipped. So when we look at the sides, we have one of the legs. When you have a right angle, the two lines that come off the right angle are called the legs. This is the leg and this is a leg. So one of the legs is 16 centimeters. We call the line opposite of the right angle the hypotenuse. So that is 20 centimeters. So when we look at these two triangles, we can see that there's the hypotenuse on both of them. And there are one of the legs. But we're actually looking for this side right here. I highlighted the wrong thing when I highlighted that. I need to change the highlighting. So one of these sides on this one is not important. I needed this leg down here highlighted with purple, not this one highlighted with purple, because it is the bottom one. So I set it up 20 to 16 for the large triangle. And for the smaller one, since I had the hypotenuse on top, I had to have the hypotenuse on top of the small one. So that would be 5 to x. Sorry about that wrong highlighting on that one. We're going to use our butterfly wings. So we'd have 16 times 5 divided by 20, and that is 4 centimeters. Okay, this one's on your notes, and you're going to see some that look like this. Here, if you look, we have a small triangle that I'm going to trace in red. We also have a large triangle, which I'm going to trace in blue. Okay, so now we have to see what we're looking for. We're looking for this side on the long triangle. So if we look at the smaller triangle, we see that we have 7 centimeters and 3.5 centimeters. But for the larger triangle, we need to know the length of this side right here. Well, they give us that 7 centimeters is from here to here. That is our 7 centimeters. And from this place to this place is 8 centimeters. So we actually have to do a little math here to figure out the length of this side of the bigger triangle. They didn't give it to us. We got to figure it out. And 8 plus 7 is 15. So now we know the length of the larger triangle on this side. Now we're ready to set up our ratios. So there's a little note there saying be careful. Sometimes you have to figure out the side if it's not given to you. We have the two sides, and then we have the two bottom sides. So when we set up our ratio, we could set it up small triangle. I actually set that one up from the base of the small triangle to the base of the larger one. And then the side of the smaller one to the side of the longer one. When we do our butterfly wings and we multiply 3.5 times 15, and then we divide by 7, we get 7.5 centimeters. Okay, this one also is your notes. Sometimes you will see triangles that this is a reflection. This one's been flipped. So you have to figure out which side matches up with another. Well, the bases are really easy. You see these two slashes right here and these two slashes right here. So this side is similar to this side. When you have triangles drawn this way, when you draw this side length, this whole line right here, that means that this side, this length, 5 centimeters, is similar to this. In the same way, if I drew this other line, which is not even indicated on this one, this green line, this side of this smaller triangle would be similar to this side of the larger. So you just draw the straight line and you know which side is similar to the other. So when setting this up, we have the two bases and we have the two sides, and we could set it up with the bases 4 to 14, and then the two sides 5 to x. And then when we use our proportions, it is 17.5 centimeters after we multiply 14 times 5 and divide by 4. Here's just one more example. It's not on your notes, but it just gives you another practice. Here you see the smaller triangle, and we know this side is 6, and we know the base is x. That's the side we're going to be looking for. When you look at the larger triangle, you will see that the base right down here is 12. And this time they give us the length. We didn't have to calculate this. They actually gave it to us. So that was nice. So there are the two sides, and there are the two bases. And we could set it up 6 to 10 equals x to 12. Then we do our butterfly wings. 12 times 6 equals 10x, and that one's going to be 7 2/10. So we're doing the proportions just like we've been practicing. We just have to set them up to find the missing side of similar figures. Instead of doing this example right here, I'm going to go ahead and pull up the paper that you're doing today. And I'm just going to show you how this paper works. If you notice on number 4 right here, we have two letters. We have a variable of s and we have a variable of y. This makes number 4 have two answers. We have to solve both of them separately. First, we have to find the missing side S, and then we're going to find the missing side Y. So to find missing side S, I know that this side is similar to this side. And now I have to use one of the other sides, but I don't want to use the one with the variable. I have to have a number. So I'm going to use the side with the number down here, the base, along with this space. So if I use those, I can set up for this one. If I do the large triangle, I could do S to 13, the diagonal to the base, and then when I set up the smaller one, I do the diagonal, which is 10, to the basis, which is 8. So at this point, I didn't need this third side over here, which is this variable y. We're going to get to this side in a minute, but we didn't need this for this part. Now when we do our butterfly wings, we're going to do 130 equals 8s, and then we're going to divide both sides by 8, and you're going to determine what s is. I will let you figure that out. Now, we need to figure out what y is. To figure out with y, we know that we're going to be using this side, because this is the side we're solving for. We're going to have to use this side, because this is the side that's similar to it. Now, we need another side with a number, so we're not going to use the s or the 10 on this one. We're going to use the one with the number, which is 13 and 8. So now we're ready to set up the proportion to solve for letter y. We could do large triangle. We could do y to 13. And then we could do 6 to 8. And then when you do your 13 times 6 and then divide by 8, you will find that answer. So on most of these, you will notice that you have two that you have to solve for. On number 5, you have to solve for letter N and letter O, two separate problems. Notice in number 6 that these are reflected, so you have to be careful about figuring out which side is which. Hopefully that gives you a good start on similar figures, and then you'll have success on your paper today.